7, where we will be talking about, well, learning about, and talking about multiplication with zeros and multiple digits, or just digits in general. So here's how you would multiply by multiples of 10, 100, 1,000, and stuff with a bunch of zeros. Multiply each number below by 10 by adding a 0 to the end of the number. For example, 6 times 10 is just 6, 0. 5 times 10 is 5, 0. Multiply each number below by 100 by adding 2 zeros at the end of the number. So if it's 2 times 100, it'd just be 2 and 2 zeros, 200. If it's 9 times 100, it'd just be 9, 2 zeros, 900. We move on to multiply each number below by 1,000 by adding 3 zeros to the end of the number. For example, 3 times 1,000 would be 3 and 3 zeros, which is 3,000. 8 times 1,000 would be 8 and 3 zeros, which is 8,000. Now we're going to find out how to do the same thing with multiples of 10, 100, and 1,000. For example, 7 times 8 is equal to 56. We all know this from our multiplication tables. 7 times 80 is 56 with 1 zero added, or 560. 7 times 800 would be 56 with 2 zeros added, or 5,600. And then we have 7 times 8,000, which is 56 with 3 zeros added, 56,000. So we have here 3 times 2, which is equal to 6. 3 times 20 would be equal to 60, which is 6 with an extra 0. 3 times 200 would be equal to 600, which is, well, 6 with 2 zeros. And 3 times 2,000, any guesses, guys? Would be equal to 6 with 3 zeros, 6,000. That's how it works. Simple, right? You just add the amount of zeros. Now we're going to multiply and do some other practice problems. Use basic facts and patterns. 8 times 20,000 would be 8 times 2 is 16, and then 20,000 has 4 zeros. So you would use 1, 2, 3, 4. 4 zeros, and get 160,000. 2 times 400, 2 times 4 is equal to 8, and this is a multiple of 100, so you add 2 zeros. 800. 5 times 7,000 is equal to 5 times 7, 35, and then 7,000, multiple of 1,000, you add on 3 zeros, and you get 35,000. 6 times 60, 6 times 6, 36. 60 is a multiple of 10, you add 1 zero, and you get 360. 3 times 9,000, 3 times 9, 27, and then you add the 3 zeros, and you get 27,000. 7 times 100, well, it's 100, so 7 times 1, 7. 100 is a multiple of 100, so you add 2 zeros. And you get 700. Well, that's it for that. We're going to move on to some problem solving. Reasonable answers. Again, sometimes in math, answers are kind of wonky. Such as, this person ate 120 wrapped candies in one sitting. Now, you're going to get into a sugar coma. Anyhow, Paul wants to invite some friends over for dinner. He has a large rectangular table and knows there is room to seat 12 people on each of the long sides and 3 on the 2 ends of his table. If Paul wants everyone to be seated at the table, how many friends can he invite? Is it reasonable for him to invite 30 people? So what do we know? We know how big his table is. What do we need to know? How many people can he invite? And is it reasonable for him to invite 30 people? So here's the math we need to do. It's 12 people on both the long sides, and there's 2 long sides in a rectangle, so that's 24 people. And then it's 3 people on each of the 2 ends, which there's, well, 2. So that's 6 people. 24 plus 6 equals to 30. The table can seat 30 people, but it is not reasonable for him to invite 30 people. Why? Because he needs a seat too. So the most people that he can invite would be 29 people. See if our answer makes sense. 29 plus 1 is the total amount of people that will be sitting. The plus 1 is Paul himself. And then 12 times 2 equals to 24. And 2 times 3 equals to 6. 24 plus 6 is equal to 30. And 30 people, which is 29 friends and Paul, equals to 30. So yeah, our answer makes sense. Moving on, use the steps above to solve the following problem. Brittany was given 3 movies to watch in her free time. Each movie is 120 minutes long. Brittany has 75 minutes of free time every day, Monday through Friday. Is it reasonable for her to expect to watch all 3 movies starting Monday and ending on Friday? So what facts do we need to know? That's step 2. What facts do we know is step 1. Technically, they're both part of understanding, but So what facts do we know? Well, we know that it's 3 movies, we know the length of each movie, and we know how much free time she has every day, these 5 days. We need to know if it is reasonable for her to expect to watch all 3 movies starting Monday and ending on Friday, which means that we need to know if it's possible. So what math do we need to do? Well, 3 times 120 is the total length of all of the movies, which is 360, and then 75 times 5 is the total amount of time that she has for relaxation in these 5 days, which is, you will be learning about how to multiply this in this manner later in the chapter, but it is equal to 375. 375 is more than 360. Therefore, it is reasonable for her to expect to finish all 3 movies. Now we reread the question. 3 movies to watch. Each movie is 120 minutes. She has 75 minutes of free time every day, Monday through Friday. And is it reasonable for her to expect to watch all 3 movies starting Monday and ending with Friday? Our facts are correct, and we also answered the question. So we're going to do these 2 practice problems to finish up this section. Nina owns her own pizza restaurant. Her profit is about $2,400 a week. That's nice. She needs to put aside $600 a week for taxes. Is it reasonable for her to spend $2,200 a week? What are you buying? Anyhow, her profit minus taxes is the amount that she is able to spend a week, which is $1,800, which is smaller than $2,200. So no, it is not reasonable because she can't physically spend that much. Well, no, unless she wants to go into debt, but debt isn't fun. It really isn't. Debt is never fun. Dimitri works 6 days a week. His total number of hours each week is 54. Is it reasonable to say that Dimitri works 7 hours a day? If he does work 7 hours a day, then 6 times 7 equals to 42, which is not 54. So no, it is not reasonable to say that. We move on to the next section. Remember that if you want to take a break at any time, feel free to do so. Use rounding to estimate products. To estimate products, round numbers. Then use basic facts and multiply. When a number is halfway between two numbers, round up, i.e. when it's a 5, you round to 10. So round the greatest factor, well, the greater factor, since there's only 2 factors right now, and you guys haven't started on multiple factor multiplication, really, to its greatest place. So essentially, you see the greater factor is 36 over here. Its greatest place is the tens place. So we're going to round to the tens place. 36 to the tens place, you look at the ones place, it's a 6. 6 is bigger than 5, which means that you are rounding up. This would be 40 times 3. And then you use basic facts and multiply. 40 times 3, 4 times 3, 12. You add on a 0, 120. Now what's the actual answer? 108. Not the worst estimate I've seen, not the best either. Usually estimation in multiplication is a lot more troublesome than estimation in subtraction or addition. So moving on. 130 times 7. 130 is a greater factor, round to its greatest place. The greatest place is, well, the hundreds place. So you look at the tens place, it's a 3. 3 is smaller than 5. You round down and you get 100 times 7. You use basic facts to multiply. 1 times 7 equals to 7, and then you add on the 2 zeros. The actual result, well, product of 130 times 7 is not that. It's actually 910, which is, well, really far off. In multiplication, it's the more you estimate, the farther away from the truth it gets. Now, anyhow, 5,267, you round the greater factor to its greatest place. So the greatest place is the thousands place. You look at the hundreds place and you get 2. 2 is smaller than 5. You round down, and that's 5,000 times 9. 5 times 9 is 45. And then you add on the 3 zeros, and you get 45,000. If you want the actual product, then you get, okay, again, I'm going to say this and ask this, why do people learn estimation before how to do the real thing first? Like, you'd think you'd learn the real thing first. Anyhow, I'm going to skip over this. We get that the actual answer is 47,403. I mean, it's not the best estimate I've seen. Not the absolute worst either, so we move on. 6,806 times 5. It's pretty obvious which one's the greater factor here. So the greatest place is, again, the thousands place. So we look at the hundreds place for rounding, and we get 8. You usually round 8 up. You actually always round 8 up, but you get 7,000 times 5, which is equal to 7 times 5, 35. You add on the 3 zeros, 35,000. Now, what's the actual solution to this? Well, product. Let's do the time skip again. I mean, it's 970 off. Not the worst, not the best. It's actually decently good. So, I mean, I take it. 194 times 2. Hey, it's 194. Pretty sure that's bigger than 2. So we're going to round the greater factor to its greatest place, which is the hundredths place. So we look to the tens place and we get a 9, which means that we round up. 200, and then you times 2. Use basic multiplication facts to multiply, and then you get 2 times 2, 4, and then you 2 zeros, 400. The actual product is 388, which isn't actually that bad of an estimate. Now, 40 times 8. 40 is bigger than 8. So 40 is a greater factor, and the greatest place is 10, but it's already technically to the nearest tens. So 40 times 8 equals to 4 times 8, 32. You add the 0 on, 320. Yay! We move on to 1,830 times 6. You get that 1,830 is bigger than 6. So you round to the thousands place, which is the greatest place in 1,830, and you look to the hundredths place, that's an 8. 8, you round up. You get 2,000 times 6 equals to 2 times 6, 12, and then you add the 3 zeros, 12,000. The actual answer is not that close, but not that far. It's 10,980 for your information. Now, 147 times 7. 147 is larger than 7. So then you get that you're rounding to the nearest hundred, and then you look at the tens, that's a 4. 4, you round down. So you get 100 times 7 again, which is 700. The actual product for this is, well, actually quite far. Since, well, 1,029 is 300 more than, well, actually no, 329 more than 700, and half of 700 is already 350, so yeah. Remember what I said about multiplication being one of the not so good places to do estimation? Especially estimation like this. Anyhow, we move on to the last question of the section. 5,265 times 4. Well, it's pretty evident which one's bigger, so we're rounding to the thousands place again. We look at the hundreds place, it's a 2. If it's a 2, we round down, so then we get 5,000 times 4. You use basic multiplication facts. 4 times 5, 20, and then you add the 3 zeros and you get 20,000. The actual answer for this is not that far off. It's slightly more than 1,000 off. And considering that that's 20,000, it's not the best estimate, but it's definitely not the worst. It's actually quite decent. So we move on to multiplying 2-digit numbers with 1-digit numbers. Such as, find 63 times 2. Here's how you would go about it. First, you would multiply the ones. 2 times 3, 6. And then you would cross over to 2 times 6, which is 12. And then you write it beside the 6. And you get 126. For another example, we have 84 times 6. So then you have 6 times 4, and that would be 24. But you can't just write 24 here. You have to regroup. So you write a little 2 over here. You could also write it down here. And then you would do 6 times 8, which is 48. And then you have 48 plus 2, which is 50. You write 50. You get 504. That's how you would go about doing 2-digit by 1-digit multiplication. You would do a crissing. Well, wouldn't exactly call it a crisscross, but you do it like this. Now, we're going to multiply and check for reasonableness. Because reasonableness is a word, it is a word. So, 5 times 2 is equal to 10, but you can't really, just put the 1 down there. You have to regroup. And then 5 times 5, 25, plus the 1 that we regrouped, 26. So we get 260. Here it's 27 times 3. You multiply these two, 3 times 7, 21. You regroup the 2, the 20. And then it's 3 times 2. Technically, you could think of it as 3 times 20, but it's recommended that you don't. 3 times 2 is 6. 6 plus 2 is 8. 27 times 3 is equal to 81. Yay! We move on to another problem-solving investigation. Robert is setting up his science project about the jungle at the fair. Okay, he has several trees at the side of a river on the left side of the display. He has birds of paradise. Birds of paradise is a umbrella term for many different types of birds that live in tropical areas. On the right side, 5 frogs are on the left side of the trees, touching the water. Are the frogs next to the birds? This is, you can use logical reasoning, or if you think that you're going to get confused, you could technically draw a picture as in river, or water. River water. Trees at the side of the river on the left side of the display, so the left side is here, and then trees at the side of the river would be here, and then birds of paradise, let's just say birds, and then frogs are on the left side of the trees touching the water, so frogs is here. Are the frogs next to the birds? No, there's trees. Trees. I'll stop. No. They are not. Question number 2, fill in the missing number. Oh, this is a pattern. 4, 12, 36, 108, something, 972, and 2,916. So 4 to 12 is either add 8 or times 3. And 12 to 36 is definitely not add 8, so it's times 3. 36 to 108, well, hey, put those newly learned skills into practice. 36 times 3. 3 times 6, 18. Regroup. 3 times 3, 9. 9 plus 1, 10. Times 3. Okay. Now we have 108 times 3. This is multiple digits and, more than 2, as in that's what I meant by multiple, times single digit, which we will be learning about in the next section. But FYI, it's 324. That's the missing term, guys. We continue. There are 6 marbles in each bag. How many marbles do you have if you are given 8 bags of green marbles, so that's 8 times 6, 14 bags of purple marbles, 14 times 6, and 9 bags of orange marbles, 9 times 6. Well then, 8 times 6 is 48, 9 times 6 is 54, and 14 times 6 is 6 times 4, 24, you regroup, and then 6 times 1, 6, plus 2, 84. You add these all up, you get 186 marbles. You have 186 marbles. Now don't lose them, or you'll lose your marbles, and you probably won't find all of them again. Da-da-da. Yeah, that was a bad pun. Julian is planting tulips. In the first row, he plants 1 tulip. In the second row, he plants 2. In the third row, he plants 4. Okay, yeah, this isn't proper formatting. You should probably write these down here. How many tulips will he plant in the 4th row, the 6th row? Well, what's the pattern? Well, we have +1, +2. That doesn't really work. At least not in the patterns that we know. So we could also do times 2 times 2. That's consistent. So he doubles the amount of tulips he plants in every row. Now for the 4th row, he would have, well, 4 times 2 is, wait, let's cross this out. 4 times 2 is 8. In the 5th row, it's 16. In the 6th row, it's 32. So he will plant 8 in the 4th row, and that's an ampersand and sign. 32 in the 6th. I know some teachers that don't like it when you use the and sign. I know some teachers that absolutely love it. So yeah, ask your teacher beforehand. I personally don't mind it, but hey, to each their own. Now, Darcy has a collection of 14 hockey jerseys. He just got a new one on a school trip. Last week, his uncle gave him 3 hockey jerseys. I am about to make a Canada joke. I'll stop. How many jerseys did he have originally? Which is basically before these 2 events. So 14 minus 1 minus 3 is equal to 10. So he had 10 before these 2 events. He had 10 originally. Guy must be a collector. Actually, no. Maybe not. I know people with a lot of hockey jerseys. Ha 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 ha, awkward laugh. Kyle was late to school all week. Okay, that takes legitimate skill. Anyhow, it's not a good skill, but still, how? On Monday, Wednesday, and Thursday, he was 25 minutes late. Okay, that's even a bigger question. How? On Tuesday and Friday, he was 40 minutes late. Okay. In middle school, that's basically one whole period. Was it though? Wait, no, a period was like 50 minutes. But still, that's an impressive amount of lateness. The principal told Kyle that he would have to stay after school and make up all the time before the end of the year. How many minutes will Kyle have to stay after school? So Monday, Wednesday, and Thursday is 25 minutes, which is 25 times 3. By a certain point in time, you just remember that 25 times 3 is equal to 75. But 3 times 5, 15, regroup, 2 times 3 or 3 times 2, 6 plus 1, 7, 75. And then Tuesday, Friday, 2 days is 40. 2 times 40 is, well, 2 times 4, and then you add a 0, so that's 80. And then that'd be 75 plus 80, which is equal to 155 minutes. Do not convert this into hours, because guess what? The question asks you for minutes. Just don't convert it into hours. He will have to stay for 155 minutes. Yay! Now we move on, finally, to multiplying multi-digit numbers. Find 122 times 6. So multiplying multi-digit numbers by a single digit is, well, really similar to multiplying two-digit numbers by a single digit, except with an extra step. So you go with the ones first. 2 times 6, that's 12. But then you regroup, and then you attack the tens, and then you get 2 times 6 again, well, 6 times 2, which is the same thing. And then you get 12 again, but you have to add the regrouped one, so that's 13. But then you have to regroup again, because there's still more. And then you attack the hundreds. And, well, you tackle the hundreds. Football tackle. American football tackle. For the Brits, it would be rugby. 6 times 1 is, well, 6. Plus 1 is 7. You get 732. Essentially, it's just two-digit numbers, except with an extra step, because, well, there's more digits. So let's do some practice problems. $184 times 4. Four times 4, 16. You regroup. 4 times 8, 32. 32 plus the regrouped 1, 33. You regroup again, and then 4 times 1, well, 4, plus 3, which you regrouped, and it'd be 736. Here we have 962 times 9. You attack the ones place first, and you get 2 times 9, or 9 times 2, 18. You regroup. You do the tens place next. 9 times 6, 54. 54 plus the regrouped 1, 55. Regroup. And then you do the hundreds place. 9 times 9, 81. Plus the regrouped 5, 86. And you get 8,658. Here we move on to even more digits. 7,294 times 3. You do the ones place first. 3 times 4, 12. You regroup. And then you do the tens place, 3 times 9, 27, 27 plus 1, 28, you regroup, 3 times 2, 6, 6 plus the regrouped 2, 8, you don't have anything to regroup, 3 times 7, this is the thousands place now, it's 21, and you don't really have anything in the 10,000s place, so you just drag the 2 down, and you get 21,882. We go back to the good old-fashioned hundreds. 411 times 6. 6 times 1, 6, 6 times 1, 6. Ones in the tens, done. Now we move on to the hundreds, and then 6 times 4, 24. But there really isn't anything in the thousands this time, so we just drag the 2 down. You get 2,466. We move on. We're back to the thousands here. 6,620 times 7. 7 times 0 is just 0. 7 times 2 is 14. You regroup. You go on to the hundreds. 7 times 6, 42. 42 plus the regrouped 1 is 43, but you can only put 1 digit there, so you regroup the 4, and then you multiply 7 times 6 again, except this 6 is in the thousands place. And you get 42 plus 4, which is 46. And there's nothing in the 10,000s place, so you just drag the 4 down. 46,340 is your answer. Now we have 159 times 2. 2 times 9, the ones digits first. 18, you regroup. 4 times 5, 10. 10 plus 1, 11. You regroup. 2 times 1, 2. And plus 1, that was regrouped, 3. Your answer would be 318. 295 times 8. Well, ones placed first. 8 times 5, 40. You regroup. Tens placed next. 8 times 9, 72. 72 plus 4, 76. You regroup. 8 times 2, 16. 16 plus, well, 7 is 23, so that's 2,360. For the last question of this exercise, we get 1,237 times 5. 5 times 7, ones placed first. 35. You regroup. Tens placed second. Well, next. 5 times 3, 15. Plus 3 that we regrouped, 18. We regroup again. Hundreds placed next. Third, hundreds placed third, hundreds placed next, whatever. 5 times 2 is a 10. 10 plus 1, 11. You regroup again. And then 5 times 1, thousands place, the last. 5 plus 1 that we regrouped is 6. 6,185. Essentially, no matter what, B, C, D, E, and then times F, you would always just go one by one. Like all vertical form, you do it from right to left. We move on to a different set of exercises. Find the value of each expression if t equals to 9. So the first one, we have t times 823. So that's 9 times 823. Ones place, 9 times 3, 27, and then tens place, 9 times 2, 18, 18 plus 2, 20, and then you regroup. 9 times 8 is 72, 72 plus the regrouped 2 is 74, and well, there's nothing in the thousands place, so you just drag the 7 down, and you end up with the answer that t times 823 is this, 7,407. Now for t times 2,827, t is 9, so that's what we get. And ones place first, 9 times 7, 63. 9 times 2, tens place next, 18 plus the regrouped 6, 24. 9 times 8, 72, plus, well, the regrouped 2, 74. 9 times 2, 18, plus the regrouped 7, 25. Well, there's nothing in the 10,000s place, so you just drag it down. You get 25,443. For t times 8,331, t is still equal to 9. We get 9 times 1, ones place, 9. 9 times 3, tens place, 27. 9 times 3 again, hundreds place, 27 plus 2, the regrouped 2, 29, regroup the 2 now again. And then thousands place, 9 times 8 is 72. Add the regrouped 2, you get 74. And because there's really nothing in the tens, thousands place, you just drag the 7 down. You get 74,979. We move on to the last exercise of this section, which is compare. Use greater than, less than, or equal to. So we have 295 times 8 and 314 times 7. Let's calculate. So 8 times 5 for the ones place, 40, you regroup. 8 times 9 for the tens place is 72. 72 plus 4 is 76. 8 times 2 is 16. 16 plus 7 is 23. And then we go on to the next one to get the other answer. 7 times 4 is equal to 28. You regroup the 2. 7 times 1 is 7, plus the regrouped 2 is 9. 7 times 3 is 21. And because there isn't anything regrouped, we just drag it down since there's nothing in the thousands column either. And we have 2,360 and 2,198. 2,360 is bigger. Therefore, 295 times 8 is greater than 314 times 7. Question number 13, we get 808, well, 3 times 808, and 5 times, 567. 3 times 8 for the ones place is Oh yeah, this is multiplication across zeros. You regroup, and then 3 times 0 is equal to, well, 0. So 0 plus 2 is 2. 3 times 8, 24. There's nothing in the thousands column, so we just slap it down. Well, drag it down. 5 times 7, ones place, 35. 5 times 6, tens place, 30. 30 plus 3, 33. 5 times 5, 25. 25 plus 3 is equal to 28. And you have 2,424 and 2,835. 2,835 is bigger. Therefore, 3 times 808 is less than 5 times 567, or 567. Now what about the last question? 4 times 876 and 6 times 584. Oh, I just drew that line a little weird. Anyhow, doesn't really matter. 4 times 6. 4, you regroup. 4 times 7. 28 plus the regroup 2. 30. Put the 0 down. 4 times 8. 32. 32 plus the regroup 3. 35. Nothing in the thousands column, so you just drag it down. We move on to the next number, which is 6 times 4, 24, regroup, 6 times 8, 48, plus 2, 50, regroup, 6 times 5, 30, 30 plus 5 is 35. Nothing in the thousands place, so you just drag the 3 down. For both of these, you get 3,504, which means that 4 times 876 is equal to 6 times 584. We move on to multiplication across zeros. Multiplication across zeros is actually really similar to, well, normal multiplication. Why? Look at this. You do the same thing. 6 times 4, 24, you regroup the 2. 6 times 0 is 0. So 0 plus the regroup 2 is just 2. 6 times 8, 48. You don't have anything to regroup to, and you get 4824, or 4,824. Essentially, you just do the same thing, except you add 0 to the regroup thing. Yeah, it really isn't all that different. So let's do some practice problems. Multiply. 2,005 times 7. So 7 times 5, 35. And then it's 7 times 0, which is equal to 0. So, well, 0 plus 3, 3. 7 times 0, which is equal to 0 again, and there's nothing regrouped, so it's just 0. 7 times 2, 14. It really isn't all that different, as you can see. 14,035. We continue. 105, or 105, times 4. 4 times 5 is equal to 20. 4 times 0 is equal to 0. 0 plus the regroup 2 is just 2. And 4 times 1 is 4. 420. See? Not all that different. What about here? 2 times 203. 203 2. 2 times 3, 6. 2 times 0, well, 0. And there's nothing regrouped, so it's just 0. 2 times 2, 4. You get 406. Here we have a very big number, as in 7,075 times 8. And then 8 times 5 is 40. You regroup the 4. 7 times 8. Oh, 56. 56 plus 4, 60. And then you regroup the 6. 8 times 0 equals to, well, 0. And then 0 plus the regrouped 6 is just 6. There's nothing to regroup right here, so 8 times 7, 56. So, yep. 56,600. We're moving on to the last two questions of this section and the last two questions of this chapter, but it's not an excuse to slack off yet. 603 times 5. Just hang in there, guys. 5 times 3, 15. You regroup the 1, and then 5 times 0 is, well, 0. And you add the regrouped 1, and you get 1. 5 times 6 is 30, and there's nothing in the thousands place, so you just drag down the 3, and you get 3,015. Here, we have 6,104 times 9. 9 times 4, 36. 9 times 0 is equal to 0. And 0 plus 3 is, well, equal to 3. So there's nothing to regroup. 1 times 9, 9. Nothing to regroup either. 9 times 6, well, 9 times 6 is 54. And there's nothing in the 10,000s place. So we just drag the 5 down. We get 54,936. Multiplication across zeros really isn't that different from, well, just normal multiplication without zeros. It's not actually different at all. Except you treat the regrouped ones slightly different. Well, that's it for this chapter. See you next chapter.